In this video, we're going to talk about topic 4 from the review packet, which is solving rational and radical equations. Remember, a rational equation has the root word ratio in there, so that's just a fraction, and a radical has to do with a root. So we're going to start with solving question number 11. Here we have 3 radicals, or rational expressions that are being added and subtracted together. And if we want to solve for x, our first job is going to be to get rid of the denominators. Now, before we can start eliminating denominators, I have to figure out what my lowest common denominator is. I'm going to multiply every single term by the LCD. And the LCD is a product of all of the unique denominators from each of these expressions. So in order to find that, I have to find all of the unique factors in these denominators. So in the first fraction, I have x minus 6 in the denominator. In the second, I have x minus 2. And in the third, I have a quadratic that hasn't been factored. So I'm going to have to factor that before I can keep going. I'm going to do that by making a quick t-chart. I'm going to have to find 2 things that multiply to 12 and add to negative 8. I can do this by factoring the number 12. I get the numbers 1 and 12, 2 and 6, and 3 and 4. And I can see that the numbers that add up to 8 are the numbers 2 and 6. And to get a negative 8, they would both have to be negative. Negative 2 minus 6. So my factors here are x minus 2 and x minus 6. Now I'm going to go ahead and have that as my denominator instead of the original one, x minus 2 times x minus 6. If I'm looking for my lowest common denominator, I want to figure out what these denominators have in common. So these denominators have x minus 2 in common, so that's part of my lowest common denominator. These 2 denominators have x minus 6 in common, and I have now used up every single unique denominator, so x minus 2 times x minus 6 is my lowest common denominator. So in order to proceed with this question, what I'm going to do is I'm going to take my original expression and I'm going to multiply every single term by x minus 2 times x minus 6, that lowest common denominator. So every single original term that I had gets multiplied by that lowest common denominator. Equals 4 over x minus 2 times x minus 6, and I'm going to multiply this again by x minus 2 times x minus 6. Now, I'm only multiplying the numerators. We're not multiplying top and bottom, we're just multiplying the top. And the reason we're doing that, if we do something to one part of an equation, we have to do it to every single part in order for it to be allowed in algebra. And if I multiply the top of a fraction and the bottom of a fraction, if I have the same factor in top and bottom, I'm going to be able to cancel them. So in my first rational expression over here, the x minus 6 can cancel the x minus 6 on the bottom. And now that expression does not have a denominator anymore. It just has the 1 times x minus 2, which is just x minus 2. So I've eliminated the fraction there, and that's the job of doing this step. All right, in the next part, plus, I'm going to go ahead and cancel the x minus 2 from the top with the x minus 2 from the bottom. So now all that's left is x times x minus 6. And on the other side of the equal sign here, the x minus 2's will cancel, and the x minus 6's will cancel, which means all that's left over here is just the number 4. And now we're going to be ready to try and solve this guy. Now we have one expression with no fractions anymore. So if I want to solve this, I'm going to have to simplify the left-hand side. I'm going to distribute this x into these parentheses. X minus 2 plus x squared minus 6x equals 4. I can see that I have an x squared in this problem, which means that I'm going to have to use factoring in order to solve it. So in order to use factoring, I'm going to try to move everything onto one side of my equation so that I can factor that side of the equation and have it set equal to 0. So I'm going to get everything on the left side. So I'm going to combine these 2 x's, negative 6x and positive x, and I'm going to bring this x squared to the front. Negative 6x plus x is just negative 5x, and I have my minus 2 equals 4. So all I did is combine like terms and rearrange things a little bit, and I'm going to go ahead and subtract 4 from both sides. So the equation that I end up with is x squared minus 5x minus 6 equals 0. And in order to solve for x, all I have to do is one more t-chart here. I have to find two things that multiply to negative 6, that add to negative 5. Those numbers are going to be 6 and 1. And in order to get a negative 5, the 6 has to be negative and the 1 has to be positive. So x minus 6 times x plus 1. Now, this is an equation equal to 0, so I can set each piece equal to 0 to find my final solutions. X minus 6 equals 0. That means x is 6. And if x plus 1 is 0, x equals negative 1. Now, before we call this problem finished, I do want to go back and double check. My original function had fractions, and these fractions had denominators that had variables in them. And it's actually very important that I go back and double check to see what happens with these denominators, to see if there are any values that I'm not allowed to use, because the one thing that I absolutely cannot do in math is I cannot divide by 0, which means x minus 6 is not allowed to be 0. So that means that x can't equal 6. Also, x minus 2 can't be 0, so x can't be 2. So if I get either one of these numbers, I'm not allowed to use it. I'm not going to do it for these guys because we've already done that. X minus 2, I can't use 2. X minus 6, I can't use 6. So the two answers that I got were 6 and negative 1, but I'm not allowed to use 6, so that's not a viable answer, which means x equals negative 1 is the only solution that I have to this problem, and x equals 6 is called extraneous. All right, let's go ahead and take a look at question 12. For question 12, again, I want to solve for x, and this one has a radical in the expression. The radical is that square root. In order to get this x out of this square root, I'm going to have to undo the square root that's happening, but I can't undo a radical unless it's by itself on one side of an equation. And right now the radical is not by itself. It has this plus x on this side with it. So my first job is going to be to get the radical completely alone. And to do that, I'm going to subtract x from both sides. So I'm going to end up with the radical x plus 5. And on the other side of my equation, I'm going to have 7 minus x, or negative x plus 7. Now that the radical is all by itself on this side of the equation, I can undo the square root by doing the second power. So I can use the exponent that matches this invisible index of 2 over here. But if I square the left side of the equation, I also have to square the right side. On the left side, the square and square root cancel, so x plus 5 is just by itself. But on the right side of the equation, I have to do 7 minus x times itself. I have to square it. I can't just distribute the squared. I have to FOIL here. So that means that x plus 5 is going to equal 7 times 7, 49. 7 times negative x minus 7x. Negative x times 7 minus 7x. And negative x times itself, which is plus x squared. So to simplify this out, x plus 5. And I'm going to rearrange this so that it's in quadratic form. The x squared should be up front. X squared. I had negative 7x and another negative 7x, so that's minus 14x. And the number 49 should be at the end, so plus, that should be 49. There we go. All right, so now I'm ready to solve for x. And I have x in more than one spot, and I have this x squared here, which tells me that I'm going to have to factor in order to find my answer. So I should have everything all on one side of my equation equal to 0. So I'm going to move this stuff, minus x to both sides, and I'm going to subtract 5 from both sides. That way, the left side of my equation is just 0. So I have nothing left on the left side. On the right side, I've got my x squared. I have negative 14x minus x, which is negative 15x. And I have positive 49 minus 5, which is plus 44. In order to solve for x, we're going to have to factor, so I can do that using a t-chart. I'm going to find two things that multiply to 44 that add to negative 15. And if I can't see those right off the bat, I can start by making a list of factors. So 1 times 44, 2 times 22, 3 doesn't work, but 4 times 11. And in fact, those two numbers do add up to 15. And they would both have to be negative. Negative 4, negative 11. So in my factors here, x minus 4, x minus 11. There we go. That's equal to 0, which will help me find my solutions. So x minus 4 equals 0. that means that x is 4. And if x minus 11 equals 0, that means x equals 11. Now these are the two solutions that I get, but they may not solve the original problem. Remember, my original problem had this radical, and when the radical is part of the problem, they have picked the sign of the answer. So since there's no sign in front of this square root, it means they want the positive answer only. So the last thing I have to do is check to make sure which one of these numbers will actually answer my question. So I'm going to plug them back into the original to see which one works. So the square root of 4 plus 5 plus 4 should equal 7. So the square root of 9 plus 4 should equal 7. And that's 3 plus 4, so that does work. 3 plus 4 does equal 7. Let's check the next one. The square root of 11 plus 5 plus 11, I'm just plugging this back into the original equation, should equal 7. So it says the square root of 16 plus 11 should equal 7. That one doesn't work. The square root of 16 is 4. 4 plus 11 is 15, which does not equal 7. So this doesn't work. So 11 can't be our answer, which means 4 is the only true solution here. 11 is extraneous. Which brings us to our last question. Our last question says, what is the value of the extraneous solution for this equation? Our last problem wants us to find the value of the extraneous solution. So it's not looking for any real solutions, it's just looking for the extra. But in order to find the extraneous solution, we're still going to have to solve this equation. Now, extraneous solutions are solutions that we're not allowed to use. So we are more than welcome to figure out which values we're not allowed to use for this function first, if we'd like to, as long as we know that we have to refer back to them at the end. I went back to them at the end of problem 11, but if you want to find them first here, that's totally fine. You have to make sure to look at the factors, which means that all the parts of your expression have to be completely factored. And this denominator here, x squared minus 1, is not factored. So I'm going to have to factor that first. Now I could use a t-chart and find two things that multiply to -1 that add to the middle value. We don't have a middle value, so they would have to add to 0. But x squared minus 1 is actually a special case. X squared is a perfect square, and 1 is also a perfect square. So this is actually a difference of squares. So what I have to do is figure out what's being squared in front, that's x, and what's being squared in back, that's 1. And it lets me find the factors, which are x plus 1 and x minus 1. Easy peasy. So instead of using x squared minus 1, I'm going to use this as my new denominator, x plus 1 times x minus 1. All right, now that we're doing that, we can make a list of the factors we're not allowed to use. So if one of my factors, x plus 1 equals 0, that's going to make me try to divide by 0, which I'm not allowed to do. So x plus 1 can't equal 0, which means x can't equal -1. That's going to be one of my possible extraneous solutions, if that's an answer that we end up getting. The other option is this other factor of x minus 1. That's not allowed to equal 0 either. So x is not allowed to equal +1 either. And if I keep going down the line, x minus 1, x can't be 1, x plus 1, x can't be -1, I have the same two answers over again. So these are the two values I'm not allowed to use. Now if I get either one of those as a solution, that's when we call it extraneous. So now let's take a look at solving this equation. In order to start solving, I need to get rid of all of my denominators. And again, I do that by multiplying by the lowest common denominator. The lowest common denominator is a product of all of the unique factors from my denominators. So I have the factor x plus 1 here and here. I have the factor x minus 1 here and here. And those are the only factors for my equations, which means that that's my lowest common denominator. So what I'm going to do is I'm going to multiply every single term in my equation by this lowest common denominator. So 2 over x plus 1 times x minus 1 has to get multiplied by my lowest common denominator. And again, that's just the numerator. It has to get multiplied by x plus 1 times x minus 1. And then if we subtract 1 over x minus 1, I have to multiply that by Oh, I did that backward. Let me keep my colors straight, sorry. Minus 1 over x minus 1. I have to multiply that by my lowest common denominator, x plus 1 times x minus 1. And last up equals 1 over x plus 1. I have to multiply this also by x plus 1 times x minus 1. So, if I multiply all of these by my lowest common denominator, then my denominators will all cancel. So this x plus 1 will cancel this one, this x minus 1 will cancel this one, and the only thing I'll have left for the term on the left is the number 2. After my minus sign, my x minus 1 will cancel here, and I'll be left with 1 times x plus 1. I left that in parentheses because of this minus. It's going to be really important that we distribute that. And all the way on the right, the x plus 1s will cancel, which means I get 1 times x minus 1, which is just x minus 1. That time I didn't put parentheses because there was no negative in front of it, so I don't have to distribute anything. Now we have an equation that we can solve. So let's go ahead and distribute this negative 1 inside the parentheses here. 2 minus x minus 1 equals x minus 1. And we'll move everything all into one side. So we'll move the x's to one side and move the numbers to the other. So I'm going to go ahead and take this 2 minus 1, that's just 1, and I'm going to move it to the other side. So minus 1, negative x equals x minus 2. And then I'll take this x and move it to the other side, minus x, 2x, negative 2x equals negative 2. And that lets me finish up here by getting x alone. Divide both sides by negative 2, and x equals 1, negative 2 divided by itself. So that's our solution to the problem. Except that that is one of the solutions that I said I was not allowed to use, x equals 1. So it is a solution to this problem, but it is not a solution to the original, which means my extraneous solution is x equals 1. It's not allowed to be used. That does it for solving rational and radical equations. We'll pick up in the next video with topic number 5.